Hey guys, welcome back, and today we are going to be taking a look at 6.4, which is amplitude and period of sine and cosine functions. And so for the think slash warm up here, I have think of the line y equals x. What happens when we change that to y equals 2x? So if we just think of our basic um, a basic graph of y equals x, right? We just have a line, like that, where, we're at the point 1, 1, 2, 2 are points, right? Which is very nice and all the way down. And when we have 2x, really, don't we just bump it up, right? So now, instead of at 1, 1, we're at 1, 2, right? Our line just is steeper now. But it kind of makes sense that we'd be at 1, 2, right? We say take whatever we originally had for y and just multiply it by 2, right? And we moved it up. So using this logic, what do you think y equals 2 times the sine of x would look like? And I'll let you think about that while we talk about this. So on the next slide I have, if we have a function y equals a times the sine of x, or y equals a times the cosine of x, or we could have thetas here, right? It doesn't really matter. Then the amplitude of those function is the absolute value of a, also, and then that's how that is written. So that's just some vocab we need to get down. And the amplitude essentially affects the maximum and minimum values for the sine and cosine. So I think it's best kind of seen with an example. So sketch the graphs of y equals cosine x and y equals 4 cosine x and compare the two. And then I ask for the amplitude. So just as a quick refresher, if I have y equals the cosine of x, when we did our graph, right, we went out to 2 pi and cut our halves in half, pi halves, 3 pi halves, and our max was 1 and our minimum was -1. And then for cosine, we start up here, then we work our way down and come back up. And that's all that one was. But as soon as we add, I'm not even going to rewrite all this, as soon as we add y equals 4 times the cosine of x, all that happens is these get changed to 4s. I'll erase that one. Right now the max and min is 4 and -4. That is the only difference. And so the amplitude is just 4. And that kind of makes sense, right? If we ignore this 4 for a second, the highest cosine could be was 1. Well, now the highest it can be is 4 times 1, which is 4, or -4. And then the lowest it could be is -1, and right, 4 times -1 is going to be -4, and that would be the lowest it can be. So it kind of makes sense that these are stretched out. And if you want to make your graph more realistic, we could say that's 3, and that's 2, and that's 1, -1, -2, -3, -4. Right? If you would like to write it out more like that. And so remember when we were talking about periods, that's how long it takes a function to repeat itself. So the period of the functions y equals sine of k theta and y equals cosine of k theta, now x's are thetas, it's really no different, right, is 2 pi over k. This is something that you'll definitely want to write down, and we just have the restriction that k is greater than 0. So again, I think it's best kind of seen with an example, and we just have to kind of remember what period means. Period is like how far we go before it starts repeating itself. So we have graph y equals cosine of theta and graph y equals cosine theta over 2. I'm not going to worry about graphing y equals cosine of theta because we already know what it looks like, right? But let's just get right into y equals the cosine of theta over 2. Well, we just said that the period is 2 pi over k. What is k here? K is really 1/2, right? Because really we have like 1/2 times theta if we're just dividing it by 2. So our period is 2 pi divided by 1/2 divided by a fraction is multiplying by the reciprocal, so dividing by half is really timesing by 2. So our period is really 4 pi, because we're going to take that 2 pi and multiply it by 2. Now, what does this mean for our graph? For our graph, when we graph this thing, our amplitude is just 1, right? We're just basic. We don't have anything hanging on the outside, so it's just 1 and -1. But now that the period is 4 pi, that means 4 pi is going to be on the end here. And that means this would be 2 pi halfway. This would just be pi. In between here would be 3 pi. And you don't always need to mark all of these, but with one like this, it might be nice just because it seems simple. And then it's the cosine again. So we are starting up here, going down. So you see, it really doesn't look different, but it would if we were to draw the graph out on the same set of axes, right? So the only reason it doesn't look different is because I've just modified how far I go out, right? So really, if I normally had 2 pi here, normally we would have this whole thing complete right here at 2 pi, but now we've kind of stretched it out all the way to 4 pi. And so what we can think here is for y equals a sine k theta, we can think that up here we're going to have a, and down here we're going to have -a for our max and our min, right? Those are our amplitudes. And then our max thing here is going to be 2 pi over k. That's our period, right? Our period is when it repeats itself, and sine kind of just looks like this. I'm doing my best to graph it. Not too great, but you guys get the idea, right? That's our shape of the sine graph, and all I'm saying here is the max is going to be a, the minimum is going to be -a, and then the period before it starts to repeat itself again, right? If I were to continue this, it would really repeat itself, is going to be 2 pi divided by this k. And so kind of the same thing for the cosine. I would definitely write these down, by the way, because this is kind of like a surefire thing. Our amplitude, again, we're just going to go up a and down a. And then our period is going to be 2 pi over k. And then we know the shape of the cosine is something like that. Where now we're just kind of like changing the bounds of where we're going, the bounds of a, and we're changing our scale, basically. We're changing the scale of x for those. So state the amplitude and period for the function y equals 1/2 sine of 4 theta, then graph it. So the amplitude is 1/2, and that's just the a that's straight out front of here. And then we have the period. Period is going to be 2 pi divided by k, which is 2 pi. K here is 4. So really what we have is pi halves, right? And so if we graph this thing, now that our amplitude is 1/2, the highest we're going to go is 1/2, and the lowest we're going to go is -1/2. All right, and then our period is pi halves. So all the way out at the end, we're at pi halves, middle, cut the halves in half. You could graph it here if you wanted. I would kind of like to at least label this one. If we cut pi halves in half, that'll be pi fourths, or oops, not pi halves, but pi fourths. And if we had this one, half of that would be pi eighths. And this would be 3 pi all over 8, because I'm really adding pi fourths each time, or I'm adding a pi eighth each time. So really that'd be 3 pi over 8. And then we just follow our normal sine curve. We start there, go up, come down, come back up. And again, it's not going to be the prettiest on this tablet, but I think you guys get the point there. So now state the amplitude and period for the graph of the function y equals -3 cosine pi of theta. Now here, our amplitude, it's not -3 because it's the absolute value. So our amplitude's still just 3. And our period, this one might confuse people right away and kind of get tricky. Our period is 2 pi over k, which is 2 pi, and then k is k is pi, k is pi, so really, the pi's cancel, and our period is 2. Now, this one might be weird to people, right? So now when we graph this, we're not going to have pi's in our graph, which feels weird, but that's just because of how it works with our period, our new period. So now our amplitude's 3. So we're going up to 3 and down to -3. And now our period, we go out to 2, which means that, I know I'm a little slanted here, so that's going to be 1, half of that's going to be 1/2. This is going to be 3 halves, right? And now, one thing to note here is we had -3, right? So when our first value, right? So if we were to just take, let's just think of y equals cosine of theta, and let's compare that to y equals negative cosine of theta. All right, so positive cosine of theta, cosine of 0 would start up at 1, right? Which in this case is 3. But if we slapped a negative out front, then it would simply be -1. We would just reverse kind of how it looks. So really, we're just, since we already have it all set up, we're starting down here now since it's negative, right? We've just kind of flopped it upside down. There we go. And that's a sketch of that graph. Last one here, write an equation of the cosine function with amplitude 9.8 and period 6 pi. So amplitude of 9.8, that means, so I'm just going to write a equals 9.8, and our period 2 pi all over k, right? Because we have y equals a cosine of k theta. We got a, we need to find k. We're saying that is 6 pi. So really, we need to multiply this k over and then divide the 6 pi over. So when we do that, we're going to get k equals times this k over, and then we're going to have to divide that 6 pi over. So then it'll be 2 pi divided by 6 pi. Pi's are going to cancel. 2, that is the same thing as 1/3. Right? So really what we have here is y equals a is 9.8, and then cosine and then we can write this as theta divided by 3, or you could write 1/3 theta if you wanted. Now keep in mind that amplitude is the absolute value, so if we really wanted to, we could also write negative 9.8. Right, just because it didn't specify, and the amplitude could be either one. But that is going to wrap up 6.4.